Hi, I'd like to show you how to get some basic tests in place for the trivia application, which JB Rainsberger has put out as an example of a refactoring kata. So I'm going to start by cloning JB's repository, and I'm going to show you how to use the tool TextTest to put in place some text-based tests using the golden master technique, which I believe JB has talked about. So let's have a little look at what we've got. We've got a version of the trivia code in various languages. I'm actually going to work with the Python version, which when you execute it, it comes up with all this on standard output. So it's playing a game of trivia, and it's a random game. When you run it the next time, a different thing happens. So let's just have a look at the code. So there's 160 lines of Python code here, and at the end there's this main method which plays a game with 3 players. So what I want to do for my text-based test initially is just to run this method and save the output as a golden copy. So what I want to do now is to start TextTest, which is a little tool which is also written in Python, but I believe you can use TextTest to test code written in any language that produces textual output. So the techniques I'm showing will work with any of the language versions. So I start TextTest with a new flag to tell it this is an application it hasn't tested before, called Trivia, and that when it's naming files to do with this application it should call them triv. I'm going to put them in a subdirectory to the current working directory, so that they're all kept together. It's not a GUI application, so I don't need the GUI testing options, and then I just need to find the executable for this program. So there, I've got the TextTest static GUI here, and this is the GUI I use for managing my test suites and my tests, and I can see metadata about them, and I can configure the way TextTest treats them. So at the moment this is an empty test suite, so I shall right click there and add a test, and I thought, well, the first test is just the random game that we looked at earlier, where I just have a test that purely executes the application. So when I run the test, it creates this new GUI for me, which is called the dynamic GUI, where I see test runs. So you can have several test runs open at the same time, and you can look at them. So here we have the one test we ran, and here we can see it's detected 2 new files. It's gathered the output on standard error and standard output, and the program produces nothing on standard error, and on standard output we get the output we saw before about the game and who's answering which question and that kind of thing. So that's what we expected, so we can save both of those files as a golden master just by pressing that button, and now it's marked the test as green because the output it got from the last test run matches the stored golden master. And if we go back to the static GUI where we can see a static view of our test suite, we've got now for this test the 2 golden copies, the standard error and standard output. So if I run this test again, it fails. The standard error is marked as green because it's still producing no output to standard error, but the standard output is marked as red because there's a difference. This time when we ran, we can see that it didn't play exactly the same way, and different questions were answered, and there was probably a different outcome. So there's all sorts of differences. So that's no good as a repeatable test. We can't rely on this because it's going to fail every time we run it, whether we've introduced an error in the code or not. So what I need to do is to make a modification in the code, which I obviously haven't still got open. So the reason for the different result every time is because of this randomness. It's rolling a dice, effectively. So what I'm going to do to control that randomness is to seed it, which is a standard technique when you have a random number, because a random number is not actually random. It uses the system clock to decide where in a particular sequence it will start. So by adding a seed, I'm telling it where in the sequence of random numbers to start, so that every time I execute the program it will start in the same place and produce the same sequence of random numbers. So now when I run my test, it still fails, but this output is actually as good as the output I saved last time. It's still a random game. I haven't made any difference to the code that is significant. I've just changed the way the randomness is initiated. So I'm going to save that as a new golden copy. So I've just clicked that button. It's overwritten the golden copy that I was saving for this test. So now when I go back to my static GUI and run this test again, it passes, because now the randomness is controlled, it's seeded, and every time I execute this test it will execute the same random game. So that's a good start. We can probably lean on this test to do a certain amount of refactoring in this code. But there will be lots of paths through this code that we're not covering with that one random game. So it doesn't give us a huge amount of security. So we have a couple of choices. We can proceed to design some tests that will provoke particular games to be played, that will provoke particular paths in the code, and that would be a question of designing test games and triggering them. Or we're going to do what I'm going to do now, which is much faster, which is just to get it to execute, say, 1,000 random games, one after another, and just record the results of them all. And then hopefully that will cover enough paths in the code that we can refactor with some confidence, and maybe design some tests as well. So I want to change the code so that I can run a lot more games in sequence. So I'm just going to add a command line flag which will let you control how many games this plays. So let me just add a little bit more code. Hopefully still this code is not going to break anything. It's hopefully a safe change to make. In Python, the first argument to the script is always the name of the script, so I have to check if there's anything else coming on the command line. So there, if there was a command line argument for the number of games, I'm now going to capture it, or if we didn't give any such arguments, we'll just run one game. And now I can do a for loop to run that many random games. So I hope you understand my Python now. I haven't done anything really to change the logic of the code. I've just run it more times if I give a command line flag. So now of course I want to create a new test which is going to run more than one random game. So again I right click on the test suite, add test, and this time we're going to run 1,000 random games, and here in this add test I could add a description here, but I think the name says it all really. And this one has command line options, so we pass in 1,000 on the command line. So now if you look at this test, it's similar to the last one, except this one hasn't got any golden copies yet because we haven't created any, but it's also got this options file which is telling TextTest what to pass on the command line. I just wanted to show you what's happening here in the file system. We've got this folder TextTests, which now has some files that TextTest has created, a config file, a test suite file, and 2 folders, one folder for each test. And if we look in the folder for the random game test, you can see there are the 2 golden copies, golden masters for standard error and standard output. And 1,000 random games, which we haven't finished defining yet, has only got the options file there. But basically you can see that TextTest is defining all of these text-based tests in terms of files and folders in the file system. That's That's what I wanted to show you. So let's see if we can execute this 1000 games test and see if it works. So again, when we executed it, it opened the dynamic GUI for this test run, and it showed us there were 2 new files it wasn't expecting. It didn't have golden copies for these ones, so that's marked as red. But we can quickly see that standard error is empty. We like that. Let's save that one. Standard output. This is a much larger file than before, but it's basically the right kind of thing that we were expecting, so let's save that as well. So now we've got 2 tests, and I can select all my tests and run them all, and they both pass consistently, so that's good. So hopefully we've now got enough confidence to go in and start refactoring this code. So I'm not going to do all the refactoring now. I'm just going to correct this little typo here, which, just to show you what happens now when I run these tests, that they detect that something's happened. Both tests have failed. The standard error is not changed, but on the standard output we've now got this diff, and as you can see, the typo is corrected all over this file. So that's good. We like that change. So I can save it there, and here on the preview I can see it's exactly the same change there, so I can save that one too. And that means I've updated the golden master copies very quickly and easily when I changed the behavior of my program in a desirable way. And I can see very clearly what it was that changed. So hopefully this technique could be useful for you if you want to try using the golden master technique to get your software under test using this using TextTest. Thank you. You can find out more about TextTest at texttest.org. Okay, I'm over now.